We're going to start our notes on horizontal and vertical lines by just observing this graph. So there's 4 lines on this graph, this line, this line, this line, and this line, and we're just going to observe for a moment. So if you look, let's look at this line first. You can see that this is the point 1, 2, okay? This is the point 4, 2. This is the point -3, 2. What you can observe is that in each case, the points have a different x value, but the y value is the same. The y value is 2. This line is the line y equals 2. Every point along this line has a y value of 2. The x value could be anything. It could be 0, it could be 3, it could be -3.5, it could be 1,000,000, but the y value is always 2 along this line. Down here, the same is true, except that the y value is always, look, I'm looking on the y-axis, -4, right? Here's the y-axis, the y value is 2. Here, the y value is -4. All of these points, this is 2, -4, 4, -4, 5, -4, 1, -4, -4, -4. Notice in all the cases, my y value is -4. So these horizontal lines have equations that look like y equals a number. And it's the number that the line is at on the y-axis, right? This is a y value. That 2 is a y value. It's this y value, it's this y value, it's this y value, and we can easily find it here on the y-axis. Now, on the flip side, these lines, so let's think about this line here, right? This is the point 3, 1. This is the point 3, -2. This is the point 3, 4. And what you notice is that the x value is the same on all of these points, because every point on this line, whether it's here or here or here or here, has an x value of 3. This vertical line is the line x equals 3. Like every point on this line has an x value of 3. Like even this point, look, this is 3, -3.5. This is 3, 1.5, 3, 0, 3, -1. Every point on that line has an x value of 3. And I can find that, I can see that it's a vertical line, and I can see that it hits this x value of 3. Same here, this one I can see, I'm looking on the x-axis, it hits the x-axis at an x value of -1, and every point on this line has an x value of -1. This is -1, -5, -1, 3, -1, -2, and so on. Okay, so some observations that I made, any horizontal line, the equation will look like y equals a number. Whereas the vertical lines, they look like x equals a number. Okay, now what's tricky about this that people sometimes forget, so we're talking about what these lines look like, and we're used to thinking, oh, well, the y-axis is vertical. It's true. So these vertical lines, they're parallel. Remember, parallel means lines that run next to each other like this. The vertical lines are parallel. They run alongside of the y-axis. Whereas horizontal lines, horizontal means side to side, they run parallel to the x-axis. So this is where it's sometimes confusing, because a horizontal line is a y equals line. Why? Because look, when I actually just observe the line, I see, oh, here the y value is always the same. The y value is always the same, right? So that's why this is a y equals. It's not like someone made this rule up. This is just how it works out on the graph. Along this horizontal line, this y value is 2, this y value is 2, this y value is 2. Okay? And then we're going to get into really talking about slope more seriously soon. We've talked about the slope of horizontal lines. The slope is 0, right? This is rise 0, run 1, rise 0, run 1. Now, vertical lines actually, they don't have a slope, so we say their slope is what's called undefined. We don't have a way of talking about that slope in math, so we call it undefined. Okay? And then just a quick note, right, that if I were to have this line here, this line, which is the x-axis, it's a horizontal line, so that line would be y equals, and what y value would it be? Well, the y value along that line is 0. So the equation of the x-axis is y equals 0. And the equation of the y-axis, that's a vertical line. We know that vertical lines have an x equals equation. So the equation of this vertical y-axis is x equals 0. Okay, the equation of the y-axis is x equals 0. So again, this is like a point of confusion because it kind of seems like the letters are flipped. But again, it's just based on our observations of this graph. Okay. So just if we're being asked to graph a line, here's the deal. If we're going to graph a line that looks like y equals a number, right? Here's what we do. We go to that number on the y-axis because this is a y value. Let's say this is y equals 3. That's a y value of 3. But the thing is we know that y equals a number is a horizontal line. Okay? So if I'm going to graph the line y equals 3, I'm going to go to 3 on the y-axis. There it is. And then I'm going to draw my horizontal line. There you go. I just graphed the line y equals 3. Okay. Now, let's say you forget. You're like, oh, crap. Which one is it? Is it a horizontal line or a vertical line? Here's what you can do. You can just be like, okay, wait. Let me think of 2 points, right? Because I only ever need 2 points to graph a line. And what I'm going to do is I'm going to make both of those points have a y value of, in this case, I used 3 as an example. So I'm going to make this point have a y value of 3 and this point have a y value of 3. It doesn't matter what the x value is. Like, let's just make it 1 and 2. Make it really simple. So when I go to graph this, look, I'll even start with a fresh graph here. When I go to graph these points, I'll say, okay, let's see, 1, 3 is here, 2, 3 is here. Oh, there it is. I remember. This is going to be a horizontal line, right? It's going to go through those 2 points, all right? To graph a line that looks like x equals a number, okay? Let's say I forget. I'm like, oh, crap, is that vertical or horizontal? It's fine. I'm just going to go like this. I'm going to say, okay, I need x equals a number, so I'm going to make x equals, let's say like it's -1. Let's say I want to graph x equals -1. I'm going to just come up with 2 points where x equals -1, okay? And then I'm just going to say like, okay, again, we'll just use 1 and 2, okay? So I'm going to go to -1, 1, -1, 2. And I can just right away see, oh yeah, here's my line, okay? What's the shortcut? I go to -1 on the x-axis, -1 on the x-axis, and draw a vertical line. The audio clue for this video is November, like the month, November, November, November. That's the audio clue. Okay, so quick examples. I'm going to graph this line. I'm going to graph x equals 4. So here's what I'm doing. I'm going to 4 on the x-axis, right? This is the x-axis. I'm going to 4, and I'm drawing a vertical line. There it is. That's x equals 4. Done. Okay, that's how quick it should be. Y equals, I'm going to -3 on the y-axis. Now look, here's what's cool, is it doesn't make sense for me to draw a vertical line right here, right? Like, if I just went to this number on the y-axis, it makes sense for me to draw a line that sits at that number. If I were to go to -3 on the y-axis and then draw this, that means the line y equals -3 is the same as y equals 1, is the same as y equals 3. That doesn't make any sense, right? So this is the line y equals -3. And remember, we always know x equals vertical line, y equals horizontal line. What's the equation of a vertical line passing through 3, -4? Look, vertical line. So right away I'm thinking, vertical line. Oh, that's x equals. And what does x equal? Boop, there it is. X equals 3. Okay, that's the x value, that's the y value. Okay, so look, we can visualize it on the graph. If the point is 3, -4, it's right here. The vertical line passing through it is this line. That's the line, x equals 3. Okay, what's the equation of the horizontal line passing through this same point? Well, I know that horizontal lines have an equation of y equals, and what's my y value? My y value is -4. So there it is. All right, it's going to be your turn to try all of this, okay? Lots of information. Feel free to reference your notes. Remember, the audio clue is November, but you're going to go back and try some of these practice questions.